Right, so what we have in here, we have in question B6 of Science Paper 1, and this question came in 2019 school certificate. Make sure you subscribe to my YouTube channel, because on this channel we learn mathematics, we learn biology, we learn Science Paper 1 as you can see, and also we learn Science Paper 2, which is chemistry. So make sure you do that, and make sure you click on the notification button so that whenever I upload a new video, you get to know. Okay, so let's go to the question. The diagram below shows the appearance of a coin when viewed above. So we have been given this coin, which is here, which is imaged in water, and then this coin is being viewed above, and this is how it appears. It is actually having two heights. It is having this height, which is from this point to this point, and then it is also having this point from this, this height from this point up to this point. So you need to understand these two heights. Whenever you have been given a diagram like this, make sure you note the appearance of a coin at two different heights. This height from this point to this point, which we normally call a real appearance. Okay, and also we have this point to this point, which we actually normally call a apparent appearance, or a apparent death, or a real death. This one is a real death, and this one is the apparent death. So those points are very, very important in such a way that you need to consider them whenever you have been asked a question which is looking like this. Okay, so now after this coin is imaged in water, this is how it appears when viewed above. And then it is having two heights, which is the real death and also the apparent death. So now let's go to the question. Okay, so the question A, we have been told to state Snell's law. State Snell's law. This is the first question which we are having. So we have been told to actually state Snell's law. Alright, so now before we can even answer that question, I want us to understand some concepts. So these concepts are very, very important in such a way that you need to know them whenever we are talking about what? We are talking about light. Okay, so let me just draw a certain diagram here. So let's say, for example, this is a boundary, and then we have a ray of light which is coming from this side. You have this ray which is coming from this side. So what is going to happen is that as this ray strikes this boundary, there is always going to be a normal ray which is going to be perpendicular to what? To the boundary. So this is the normal ray which is perpendicular to the boundary. So now, as this light ray is passing from one medium to another, let's say, for example, this is this medium. Okay, this ray is coming from air, then it is going into what? Into water. So what is going to happen is that this ray of light is passing from the air into what? Into the water. What is going to happen is that this ray of light is going to bend. And an important concept which I want you to understand is that whenever a ray of light, because we all know that air is less dense than what? Than water. So whenever a ray of light is actually passing from a less denser medium to a denser medium, this ray of light is going to bend towards the normal. I hope you're getting it. So whenever a ray of light is actually passing from a less denser medium such as air into what? Into a denser medium such as what? Water. This ray of light is going to bend towards this normal ray. I hope you have gotten that. But whenever a ray of light is actually passing from a denser medium, let's say, for example, in a case whereby it is coming from water, it is going into what? Into the air. So as I was saying, we are going to always have a normal ray. So what is going to happen is that whenever a ray of light is passing from, or is actually passing from a denser medium to a less denser medium, what is going to happen is that it will be vice versa as it happens when it is coming from a less denser medium to a denser medium. This ray of light is going to actually bend away from the norm. And this is what we call a refraction of what? Of light. I hope you are getting it. So whenever a light ray is passing from a less denser medium to a denser medium, this ray is going to actually always bend towards what? Towards the normal. And then whenever a light ray is passing through or is passing from a denser medium such as water to a less denser medium, this ray of light is actually going to bend away from the normal, and two angles are going to be formed. So this angle, in this case whereby this ray is coming from this side, is coming from the air, this angle which is here is what we call the angle of what? The angle of incidence. This is the angle of what? This is the angle of incidence. Then whenever this angle is formed, this angle which is going to be formed here is what we call the angle of what? The angle of refraction. Okay, the angle of refraction represented by what? By R. Then this angle is represented by what? By I. I hope you are getting it. So those are some of the important points which you need to know. Whenever a light ray is actually coming from a less denser medium to a denser medium, a ray of light is going to always bend toward the norm. But whenever a ray of light is actually coming from a denser medium to a less denser medium, is going to bend away from what? From this normal ray. So those are some of the concepts which I wanted you to actually understand before we can even start answering this question. Okay, so now let's start answering our question. So question 1, we have been told to actually to state Snell's law. So what does Snell's law state? Okay, so in talk of Snell's law, let me just give you this. Okay, so this is the solution for question 1. This expression okay, so this is how you can summarize Snell's law. In case you actually forget the words of the law of Snell's law, so in case you forget the words, you can just write this expression, and this expression simply states what exactly Snell's law states. Okay, so now what does Snell's law state in words now, since we have actually given it into this expression? So Snell's law states that the ratio of the sine of the angle of incidence to the sine of the angle of what? Of refraction is a constant. So that is what Snell's law states. So Snell's law states that the ratio of the sine of the angle of incidence to the sine of the angle of what? Of refraction is what? Is a constant. So that is what Snell's law states. Okay, so let me just write it so that in case you are copying, you are able to write. Okay, so Snell's law states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. So this is what Snell's law states. Okay, I hope you have gotten that, and I hope you have gotten 1 or 2 points from what I have explained. In case you forget this explanation, make sure you actually remember this expression. Okay, sine incidence over sine refraction is what? Is a constant. So this is Snell's law. Okay, so this is Snell's law. If you actually want to write it in expression. So this is all about question 1. Let's go to question 2. Okay, so question 2, we have been told to actually explain what will happen to this ray of light as it passes from this medium, which is water. Okay, as you can see, this ray is coming from water. As you can see, these arrows, this ray is coming from water into what is going to what into the air. So now, what is going to happen at the surface of this of the water? What is going to happen at the surface of the water is this ray is coming from the water into what into the air. So this is what exactly I was explaining. So the only concept which you need to master here, which you need to understand in this concept, I do not want you to actually forget it. You can even put a star. You need to understand that whenever a light ray is actually coming from a denser medium, such as what? Such as water, and is going to a less denser medium such as air, this ray of light is going to actually bend away from the norm. This ray of light is actually going to bend away from the norm, and that is exactly the answer for question what? For question 2. So the ray will bend away from the norm. In case you have been told to actually give a reason for your explanation, or why is it that this ray will actually bend away from the norm, the answer is very, very simple. Because this ray is coming from a denser medium to a less denser medium. Okay, so that is all about question 2. Let's go to question 3. I want you to understand this question because, as you can see, we have been given 2 marks. Okay, so the question is saying, calculate the refractive index of what? Of water. And here we have been given 2 marks. So I've been told to actually calculate the refractive index of what? Of the water. Okay, so now, for you to calculate the refractive index, the first thing you need to know, you need to actually understand the formula. So the formula for us to calculate the refractive index, this is the formula we normally use. Okay, so the formula we normally use is this: real depth over apparent depth. So always the refractive index is represented by what? By the letter N. So now, what is this same real depth and what is this apparent what? Apparent depth. So now we need to go back to our diagram. So that's why I was actually telling you to say you need to understand these 2 heights. Okay, so as I was saying, from this point up to this point where the coin is, where the actual coin is, this point, from this point up to this point, this is the real depth. And then after being viewed from this point of view, after being viewed above, this coin is actually showing, or this coin is being viewed from this point as if it is on this point. Meanwhile, it is on this point. It is below here. So now this height from this point up to the surface of the water, this height, the one we actually calling the apparent what? Apparent depth. I hope you have gotten that. And according to the data which you have been given, from this point up to this point, which is the real depth, this is the centimeters which have been given, which is 15 centimeters. So what we are going to have is the real depth is what? 15 centimeters. Okay, what about the apparent depth? From this point up to this point, which is this point up to this point, this is 11.28. Okay, 11.28 centimeters. Okay, so these centimeters and these centimeters will cancel, and then we are remaining with 15 divided by 11.28. So what you are going to have, if you punch on a calculator, you are going to have something like 1.3, then 1.329 and something like this. So now, for you to actually give the answer, you need to leave this answer in 3 significant figures. So what you are going to have is 3.33. Remember, this centimeter and this centimeter have been cancelled. So what you are having is something like this. The refractive index has got no units because of the cancellation of these 2 centimeters. So that is the answer for the last question. Make sure you understand these concepts. Make sure you master these concepts. It is very important for you to know this topic. So in summary, what I was trying to say that this depth, which is from this point up to this point, up to the point where the actual coin is, from the surface of the water up to the point where the actual coin is, this height is called, or this depth is called the real what depth, and it is the one which is always on top. And then from this point up to this point where the coin is being viewed, when this coin is being viewed above, from this surface of, from this point which is the surface of the water up to this point, so this height, the one which is referred to as the apparent what dash. So that is what we need to actually understand. This is the apparent what depth. So you need to know that, you need to understand that. And then the other point which you need to know is that whenever a light ray is actually coming from a denser medium to a less denser medium, that light ray is always going to actually refract away from what? From the normal. So this is the normal ray. This is the normal ray. So this is a denser medium, then this medium 1 is a denser medium, medium 2 is a less denser medium. So what is going to happen is that this ray is going to refract away from the normal. But whenever a light ray is coming from a less denser medium to a denser medium, so this ray of light is actually going to refract towards the normal. So that is what we call refraction. And remember always that this angle is the angle of what? Incidence, and this angle is the angle of what? Refraction. This angle, the angle of incidence, is represented by the theta I. Then the angle of refraction is represented by the theta R. So those are the points which I want you to actually know and master. And then when we talk of Snell's law, we are just talking about the ratio of the sine of the angle of incidence to the sine of the angle of what? Refraction. So this is Snell's law in expression. So this is Snell's law what in expression. The ratio of the angle of the sine of incidence to the sine of the angle of refraction is what? Is a constant. So this is a question I wanted us to actually do, and I hope you have gotten 1 or 2 concepts. In case you have liked this video, make sure you put a like and make sure you put a comment. In case you have got any questions, make sure you actually put them in the comment box. And in case you want to reach out to me, I have created a group which is very important to you, which I would like you to actually join. So if you want to join a group, just inbox me on WhatsApp using my Airtel number, which is 0976 97 58 98. 0976 97 58 98. And also don't forget to actually follow me on Facebook. Okay, you can just search me, Mr. Distinction. Okay, Mr. Distinction. This is the Facebook page name. So just search Mr. Distinction and you are going to find me. Make sure you actually follow me for any updates. Otherwise, for now, you are going to end here. Make sure you keep on checking on my channel because I'll be uploading the videos frequently. And make sure you actually put a like and a comment if you will be finding my videos to be very helpful. Otherwise, we end here. Thank you very much.